Hi, I'm John Russell, editor of HPCwire, and with me today is Dave Turek, VP of HP Systems at IBM. Hope you're having a good show so far, Dave. I was hoping that we could talk about a few things, but mostly I'm interested in what you see, how you see accelerated computing, advanced computing moving forward. And I thought maybe we'd start with the most advanced of that would be the Coral project. Could you give us a little bit of an update?
Thanks, John. Great to be here. Coral project is going quite well. The way the contract has been structured for IBM is with a series of development milestones to make sure that we don't get off track and to make sure that requirements are properly being met. To this point, every milestone has been met. All the progress is going along great. The invention that we're required to do for this project are progressing very effectively, very efficiently. We're in good shape.
I would like to touch bases on NSCI. You probably know that there's this panel later today, not a panel, invited talk around NSCI and its progress so far. And I guess the implementation plan was due within 90 days, which was a few days ago, and I guess they met it. Haven't heard much about it. I'm hoping to get your take on the role NSCI can play both in driving exascale kinds of systems as well as democratizing HPC.
It was, of course, very exciting to see this come out earlier this year, and the progress that's been made on this has been impressive. I think there are two things that are important to us from our perspective. One is the consolidation of activity in the U.S. government and the focus with the management model that's been outlined is quite critical to ensure that we move along as crisply as possible. So speed is always our enemy. Having an effective management model in place helps quite dramatically. The other thing is, when the executive order came out, it quite explicitly talked about reflections of the benefits of this within U.S. industry from the sake of competitiveness. Our expectation is that over the course of time, industry will have a very loud voice in terms of what a lot of the technology issues are and the directions are that come out of this. And I think that's the way we really get to this issue of democratization. This is not just a bailiwick that's going to affect the issues within the government. It's something that'll transcend that and actually present value to the economy at large.
You know, along those lines, do you think HPC as a service, for example, is something that will perhaps get a boost from this effort? In other words, the idea of cloud-based delivery to a broader enterprise market, people who could use it and help revitalize not revitalize, but just have some energy within industry. Is that something you think might happen?
I think there will be a lot of stimulation in terms of interest in what's happening here. I think cloud will be an integral part of it. I think there is a lot of innovation coming in the software area to really materially affect the difficulty of programming parallel computing. The emergence of frameworks like Spark and so on help quite substantially in that regard. And the essence of HPC is evolving. I mean, the inclusion of progressively greater and greater amounts of data really require and demand of the industry better programming models. So I think application frameworks will go a long way to complement the work that's been done on cloud and other areas to really push this forward in the economy.
You sort of anticipated one of my next questions, which is the notion of the data-centric paradigm, and certainly Spark and things like that. And IBM has announced very strong support of Spark earlier this year. Can you talk maybe just for a second about that, the shift to data-centric, or the collision between traditional modeling, HPC, and data-centric science?
Well, for us, this has been at the heart of our strategy going forward. And the reason for that is we observed some number of years ago that the dramatic growth of data from all the kinds of conventional ways that people have talked about it, including now the Internet of Things, really puts a demand on our industry to make an accommodation with respect to how we do modeling and simulation. Clearly, the more data you have, the richer the insight that one can gain from the analysis that gets executed. So it's incumbent on us to design systems that are accommodative to the dramatic increases of data that we're seeing. Our strategy is really quite centered on that, and we're making material changes to our underlying architectures to accommodate these kinds of data flows. Absent that, simulation and modeling just stands as an island in isolation, and its value is quite diminished.
Talking about the the paradigm change generally, one with data-centric, but also with the notion that silicon is kind of running out of steam a little bit as a way to speed up workflows. Can you talk a little bit about the accelerator-assisted computing generally? So as Moore's law slows, although Intel has a different idea, you probably heard the keynote where they're saying Moore's law is alive and well. We're kind of not seeing that when we talk to people more broadly. But the idea that accelerated assisted computing is required to get the kinds of performance gains we want. Could you talk a little bit about how that will be achieved and maybe where some of the acceleration can be embedded?
Sure. And I'll draw a distinction between accelerators and acceleration. Acceleration is something that is a fundamental part of one's architecture. And in our case, in this era of big data, we've done a lot to dramatically reduce what I call data-induced latency, the passive movement of data from one part of the infrastructure to another that's just waiting for processing to be done when it arrives. That's fundamentally embedded in our architecture. We augment that, amplify it, and complement it by the incorporation of accelerators that then further, in the analytic context, apply tremendous amount of compute power to elements of that data to really radically improve overall performance. So we see applications that one can increase quite dramatically with in our case, GPUs, and in some cases, FPGAs. But one has to deal with the totality of the problem. If the focus of acceleration is solely on an algorithm, you may find yourself working on the margin of the problem in terms of importance to the institution. That's another way of saying data is becoming such a dominant feature, you have to have equal emphasis on the management, the ingestion of data, factoring it, presenting it, and so on. So it's the workflow that has to be optimized. Accelerators play a tremendous role in terms of helping to accelerate that, and the overall architectural principles embodied in our data-centric computing models really help to deal with the issue of acceleration at large.
Great. Thank you. A good answer. I'm sort of we're all looking at the accelerator model internally in our company too, trying to figure out what it is, what to call it, how to cover it. Lastly, I kind of wanted to get your impressions on the conference so far. How is it going? Have you seen any sessions that are particularly interesting to you? Have you seen any themes maybe you could share?
Well, yeah, I think clearly one of the themes that's speaking loud and clear is this issue of data-centric. You see the terminology represented in booths all over the floor. It's akin to where we were several years ago when cloud first became kind of the new normal and everybody latched on to that terminology. So that's critical. I think the other thing that is emerging and will prove to be dramatically important in the coming year is the addition of cognitive capabilities to HPC and modeling. So whereas now we're getting comfortable with the idea of classic HPC being melded with data analytics, big data, I think a year from now you'll see the third leg of that triangle be in place, which is cognitive. And that to me is really where the substantial amount of value will be presented, enhancing the conventional way people think about HPC.
Well, thank you very much for your time. It will be fun to watch the cognitive computing paradigm sort of roll out. It's very exciting to think of machines becoming much more intelligent and able to make decisions and inferences that we can't do. You can think of, I know that Watson does a bunch of that around medicine already, but there are so many areas where you could apply that. So thank you very much.
You're welcome. Thank you, John.